Welcome back. Let's continue about the two-port network analysis. Okay. Therefore, let me redraw. If you take two-port network analysis, this is what is our two-port network. I think if you have drawn already in the last session, that is fine. Therefore, this is what is defined with V1 and current entering is I1 and defined with V2 and I2, making it two-port network and then one terminal common for both input and output. Okay, this is what is our V1 and the input current is I1, this is V2 and output current I2. Okay, now I want to characterize the black box, right? If I want to characterize the black box, we have V1, I1, V2, I2. With respect to V1, I1, V2, I2, we need to characterize. If I want to take like V1 because of V1 what is I1, because of V1 what is I2, because of V1 what is V2, or because of I1 what is I2, because of I1 what is V2, because of I1 if there is a current source excitation what is V1, right? There are many combinations, but I want two variables. We have four variables here. I want two variables to define a ratio, whether it is V1 by I1, I1 by I2, I1 by V2, whatever it may be. Therefore, now tell me how many, like for example, we have four variables. Out of four variables, I can take two variables at a time to define a ratio, right? Then how many combinations you'll get? We will get, if you take two at a time, then you'll get 4C2 combinations, because we have four variables. Then I need two variables at a time to define a ratio. Therefore, you'll get 4C2. What is 4C2? 4 factorial divided by 4 minus 2. 2 factorial into 2 factorial. If you calculate what is this, you'll get 6. Right? What do you mean by you'll get 6 combinations? Combinations in the sense, therefore I can say number 1 Z parameter model, number 2 Y parameter model, and number 3 H parameter model and G parameter model, and ABCD are transmission parameter model. The last one, which is inverse transmission parameters or inverse ABCD parameters, right? You will get 6 combinations. Therefore, each combination, right, with defined ratios like voltage by current only, okay? And then maybe if you take Y, current by voltage, hybrid, mixed, then the reciprocal of that is G, then T, input port to output port, then T inverse, output port to input port, right? That is like the Nuttall loss, etc. So many things are there related to that, but whatever may be, this is what is the one which we use. Remember, each combination set, right, will be having a different applications, right? But what I want to say, you can pick up one of the models to define your black box, then you can go ahead, right? But which one suits best with respect to the application, that is what people consider. Let us say transmission line theory, where we are giving input power, which is V1 I1, then output power to the substation or the load V2 I2, then in between we have the channel or transmission line. Then I want to know output to input, therefore we can characterize the channel. Therefore, we need to define with respect to V1 I1, V2 I2, then that is what your T parameter model. Similarly, if you take Z parameter model, right, maybe just to explain, if you take Z parameter model, right, what is that? V1 is equal to Z11 into I1 plus Z12 into I2. Similarly, what is V2? V2 is equal to Z21 into I1 plus Z22 into I2. This is what your Z parameter model. Why it is called Z parameter model? If you take all Z parameter values or the units, they are having impedance units. Therefore, tell me what is Z11? That is V1 by I1 when I2 is equal to 0. What is Z12? V1 by I2 when I1 is equal to 0. Z21 V2 by I1 when I2 is equal to 0. Z22 V2 by I2 when I1 is 0. Whatever it may be, it is always ratio of voltage and current. Therefore, this is impedance parameter. Therefore, using impedance parameter or Z parameter model, where we are trying to replace the black box with these equations, and if you know Z11, Z12, Z21, Z22, and there is a methodology to find those parameters. After finding those parameters for the black box, then for any input, for any kind of input, we can find output voltage, output current, or input current. Therefore, indirectly, we don't need what is that inside the black box. Once I characterize my black box with any one of the models, then if you know that model parameters, then for any input, we can get the relation between output to input. That is what is, right? Let us say amplifier. Then if I give a signal at the input, I want to know what is output, right? If I know Z parameter model, yes, I can find output, right? Therefore, that is what is the advantage of two-port network analysis. But before that, we should know the values of Z11, Z12, Z21, Z22. Then only we can get the relation between output to input. Then we can respond and then we can get it, right? Then maybe we have different models, but which one you use for BJT? Normally people use BJT, right? Normally people use a different model other than Z parameter model for your BJT. There is a reason. Let us take the reason. For that, let me explain first of all what is H parameter model. If you take H parameter model, H is nothing but hybrid parameter, right? Where all parameters will not have the same ratio, like it's not voltage by current ratio. It is combinations or hybrid combinations, okay? H parameter model. Then what is our V1? V1 is equal to H11 into I1 plus H12 into V2. Then I2 is equal to H21 into I1 plus H22 into V2. Right? Now let us see what is H11. H11 is V1 by I1 when V2 is 0. Therefore, H11 is giving V1 by I1 when V2 is 0. Don't bother about that condition. Now let's see the ratio V1 by I1. Therefore, that is nothing but input impedance. Input voltage by input current is nothing but input impedance. Okay, fine. What is H12? V1 by V2 when I1 is 0. Okay, therefore what is the ratio? V1 by V2. Actually it is input by output. If you know output by input, that is what is your voltage gain. But this is input by output. Kind of what? Reverse voltage gain. That is what people call it as reverse voltage gain, which is not actual voltage gain, which is reverse voltage gain. The significance of reverse voltage gain, you will get it. Now, what is H21? I2 by I1, which is nothing but output current by input current. Yes, that is nothing normal current gain. Normally people call that as forward current gain. Because we used reverse voltage gain, therefore the complementary of reverse is forward, therefore forward current gain from input to output. That's fine. What is H22? I2 by V2 when I1 is 0. Therefore, what is I2 by V2? I2 by V2 is nothing but output admittance, not impedance. 1 by reciprocal of that admittance is nothing but your impedance. Therefore, we are able to see input impedance, then output admittance or output impedance, current gain, forward current gain, reverse voltage gain. See, for any amplifier, in the introduction class, I told if you take any amplifier, that too under AC analysis, we are looking for some AC parameters, right? Out of 23 AC parameters with respect to op amp, we are mainly concentrated about 4 parameters for your BJT amplifiers and MOSFET amplifiers, right? Therefore, for small signal low frequency analysis, they are voltage gain, current gain, input impedance and output impedance. If you take H parameter model, giving input impedance, giving output impedance, giving current gain and giving reverse voltage gain, therefore indirectly we are able to see the transistor parameters which we need for amplification, which we need for amplifier. Therefore, it is better to go ahead with H parameter model. It doesn't mean that only if you go ahead with this, we will get amplification parameters. No, you can go ahead with Z parameter model. You can go ahead with G parameter, T inverse, anything. But you need to do post processing to calculate voltage gain, current gain, input impedance, output impedance, because ultimately we want the 4 AC parameters associated to your amplifier, because we are going ahead with the amplifier. Okay, write down. Later on, let us use these equations to convert these equations into equivalent circuit, and let's replace the black box with the equivalent circuit represented by the equation. That is what is called BJT H parameter model, which we use later on to solve all the problems, or to solve all the formulae, or to derive all the formulae. Okay, write this. Then let us change the subscript with respect to the meaningful unit. Then we can continue. We can replace the black box with the H parameter model. Take it. Let me replace the subscript. Okay, now can I write it like this? V1 is equal to, what is H11? V1 by I1, which is nothing but input impedance. Therefore, let me call this as HI. I is indicating input impedance. Therefore, HI into I1 plus what is H12? V1 by V2. I told you reverse voltage gain. Therefore, the subscript is HR into V2. Similarly, what is I2? I2 is equal to, what is H21? I2 by I1, which is forward current gain, HF into I1, plus what is H22? I2 by V2 when I1 is 0. Therefore, I2 by V2 is nothing but output admittance, HO into V2. I didn't do anything. Remember, just replace the subscript with respect to the meaningful unit notation. Okay, continue. Okay, until unless I say don't write, you can continue. Therefore, you can continue. Then let me use these equations. Let me use these equations to replace or to get equivalent circuit to replace the black box. That can be used for BJT. Okay. Okay, now listen, don't write anything. Okay, tell me from KVL and KCL, we know that left hand side this is voltage, definitely right hand side it should be voltage. Can we equate voltage and current? Can I say 1 ampere is equal to 2 volts or 1 ampere is equal to 1 volt? No, current is current, voltage is voltage. Therefore, we cannot equate voltage to current. Therefore, when I say left hand side this is voltage, definitely right hand side it should be voltage. Similarly, left hand side this is current, right hand side it should be current only. Okay, that is clear. Now this is voltage, definitely it should be voltage. Then can we add voltage and current? No, right? Therefore definitely this should be voltage, this should be voltage. Overall that is a voltage, that voltage we are trying to equate to something, right? I'm just speaking with respect to KVL or KCL. Now it should be voltage, it should be voltage, right? And these two should be added. Then can we add two voltages? When they are in series, we can add two voltages, right? Therefore, the quantity whatever it is representing here as a voltage, the quantity this is also a voltage. We should keep these two branches in series. Therefore, the voltage drop from this branch, we can add. That is what you get it as V1, because V1 is your input voltage. V1 is your input voltage and I1 is input current. Let me replace that. Okay. Now if I replace, therefore this is nothing but your V1 and this is your I1. This is what your input port. We are trying to replace the black box with the mathematical equations. Then V1 is equal to I1 is nothing but your input current. Okay. Then to get this as voltage, what should be HI? Current into something is equal to voltage. Therefore that HI should be resistor. Therefore if HI is a resistor, which is HI, then I1 into HI is nothing but the voltage that plus something. We know that V2 is nothing but your output voltage. Then we know that this is voltage, it should be voltage, this is also voltage. And V2 is voltage, then what should be HR? That should be a constant, and whatever term you get or whatever branch you are getting, both should be in series to add the voltages. Therefore, that is what is dependent voltage source. This is nothing but HR into V2. Remember, Normally dependent voltage source and dependent current source we represent with rhombus or diamond symbol, but as far as you know that is dependent voltage source, that is fine. Any notation is okay. Normally people represent rhombus or diamond symbol, that is fine because we know that it is depending on HR into V2. HR is constant into V2, it is depending on output voltage, therefore dependent voltage source. Therefore input side KVL is over, therefore apply KVL. V1 is equal to the drop across this plus the voltage drop across this. Therefore V1 is equal to I1 into HI plus HR into V2. Therefore this equation is replaced with the equivalent circuit. That is fine. Now similarly let's write the output current equation. And remember the one terminal is common for both input and output. Therefore this terminal is common for both input and output. And this is what is your output voltage V2. And this is what is your output current I2. Okay. Now let's see the second equation. This is current. Definitely it should be current. It should be current. When can you add two currents? When they are in series, right? No, in series current is constant. That is what is true for voltages. When can we add two currents? When two currents are in parallel. When two currents are in parallel, let us say this current plus this current adding and then coming out, or this current is equal to this current plus this current, anything, depends on direction. Therefore that is nothing but KCL, right? Therefore this current is equal to this current plus this current. Therefore whatever you represent, right, both should be in parallel. Then one of them, we know that this is current, this should be current. I1 is input current, then HF should be constant. Therefore this is dependent current source. Therefore this is dependent current source. And what is that? That is nothing but HF into I1. That is what is your dependent current source. Plus we need one more branch which is in parallel to that current source. Therefore this current plus that current will be equal to I2. What is that? That is nothing but HO into V2. Can I write HO into V2 something like this? Where V2 divided by 1 divided by HO. If I write V2 divided by 1 by HO, which is nothing but V2 into HO, because I want to write in the form of current. Voltage by resistance is nothing but your current. Therefore what is the resistance value? 1 by HO, and the voltage across that 1 by HO is nothing but V2, right? Therefore in parallel to the current source is nothing but the resistor having the resistance value 1 by HO. Therefore now if you apply KCL, what is that? I2 is equal to this current plus this current. This current is nothing but HF into I1 plus the current through 1 by HO is nothing but voltage across it is nothing but V2 divided by 1 by HO, which is nothing but V2 HO. Therefore the equations, the H parameter model equations are used to replace the black box, and we got equivalent circuit. Remember this is what is BJT H parameter model. I already explained what is model, right? Therefore this is what is model, representing the physical action with or replacing the BJT with some equivalent circuit. That equivalent circuit is serving the purpose of BJT operation under AC signals or under AC analysis. Okay, draw it. Therefore now the black box is replaced with, the black box could be anything, but now we are using it for BJT. Therefore when you use it for BJT, that too for small signal AC analysis, therefore this is what your equivalent circuit, then small v1, small I1, small v2, small I2. That is what it is. Okay, take it. From now onwards the BJT will be replaced by H parameter model, and then we will continue and try to get the relation between input voltage, output voltage to input voltage, or output current to input current, input voltage to input current, output voltage to output current. That we can use, this equivalent circuit we can use to continue. Over? Okay. Now write down, two-port network path is over. Now write down amplifier AC parameters. Write down amplifier AC parameters. I am going to use this equivalent circuit to define the AC parameters: voltage gain, current gain, input impedance and output impedance. Okay. Then you may have one doubt, that is, I told HI is nothing but input impedance, HR is nothing but reverse voltage gain, HF is nothing but forward current gain, HO is nothing but output admittance. Then if you know already BJT input impedance, reverse current gain, reverse voltage gain, forward current gain and output impedance, directly you can take HI and all. But why do we need to calculate again, right? But that is what I am saying now, saying that BJT AC parameters we are going to use this to calculate. Already we have, then why do we need to calculate? Yes, to clarify your doubt, we know already, you yourself will tell. What is HI? V1 divided by I1, when V2 is equal to 0. What does that mean? When output is shorted, when V2 is 0 means when output is shorted, whatever current you get I1 because of V1, then if you take V1 by I1, that is input impedance. No, that is not my real input impedance. The V2 could be anything, right? We should not say that short V2, then take V1 by I1, that is input impedance. No, right? That is what is basically your HI. Only when V2 is equal to 0, this V2 is equal to 0, then it is short circuit, then that is actually your input impedance. No, right? Your output is, means you are going to connect load, let us say audio amplifier, loudspeaker is connected. When loudspeaker is connected here, right, then V2 is not 0, there is a signal which is what is processed and given to loudspeaker. Loudspeaker is giving it to, loudspeaker is converting into mechanical signal and giving huge sound. Therefore, your V2 is not 0. What it may be, the V2 can be anything, V2 can be anything, right? But I want to know what is V1 by I1 irrespective of V2. That is the reason why we are calculating irrespective of all those conditions. V2 0, I1 0, V1 0, I2 0, right? That is what we have, HI, HR, HF, HO, right? We want to know the respect of all those in the fundamental definitions of your amplifier. That is what we need to calculate. Okay? Write down BJT AC parameters. BJT AC parameters. We are concentrating on only 4 AC parameters: voltage gain, current gain, input impedance and output impedance. Okay? Now we got to know the equivalent circuit of BJT using H parameter model that can be used to derive all AC parameters. Therefore, now let us say this is what is your BJT amplifier. This is your BJT amplifier. BJT amplifier. Okay. Now your output. This is your output. This is your input, right? Now let us say your output is connected. Let me say the common terminal is ground. Okay. The common terminal is ground. Let me take the common terminal. Let us say ground. Then you can define your output at ground with respect to ground. Input we can define with respect to ground. Basically, the common terminal is common. Okay, that is fine. Now this is what is the load. Let us say this is what is my RL and this is what is my output voltage V0. Okay, and let us say, let me apply either voltage source or current source, anything is fine, but let me exert with voltage source. Okay, or later on I am going to explain with current source also what will happen, but let me exert with voltage source. Then remember, it's better because let us say from the lab, if you configure, or if you connect any circuit in the breadboard, then we are going to give a source, right, voltage source to the amplifier. Then we will see whether it is amplifying the signal or not, right? Then we should give that signal from function generator. If you take function generator, definitely the function generator will have some source resistance, because no voltage source or no function generator ideal. Definitely will have some source resistance. Or let us say this is multi-stage amplifier. If this is multi-stage amplifier, this amplifier is driven by some other amplifier, then that amplifier will have some output impedance, then it will have output resistance and then output voltage. Therefore, that is what your practical voltage source. Let us excite with practical voltage source and then let us calculate the parameters. Okay, whatever may be, I am just taking practical voltage source. If it is ideal voltage source, take Rs is equal to 0. Okay, that is fine. Now, but I am taking AC source. This is nothing but small Vs, because we are doing small signal AC analysis. Okay, now only AC signals we need to apply. Whatever may be, this is Vs and then Rs, but ultimately the input voltage what you are applying to your amplifier. Let me speak with respect to two-port network. Let me take it as V2, okay, output voltage, and this is what your V1, okay, and the input current, the current which is entering into your amplifier is I1, and the current which is entering into your amplifier is I2. Okay, if you are confused with respect to ground, okay, then what I can do, maybe if you are confused, typically you may have, but as we continue the confusion will go. Then what I do, let us take this as a common terminal. Therefore, this is what is our common terminal. This is what is our common terminal. This is what is our common terminal. Therefore, and this is what is the voltage source we are applying, and this is what is the load, and this is what is our output voltage V2, and this is the load. This is the load. Okay, with respect to two-port network analysis, or yeah, this is what your V2. Maybe if you are confused, therefore this is what is your V2, right, and this is your RL. Okay, everything is fine, because I want to configure with respect to V1 I1, V2 I2. Therefore, this is what is according to two-port network analysis, but actual source is connected and the load is connected. Now we need to calculate the BJT AC parameters. The heading is AC parameters. Okay, AC parameters. Okay, right, now we need to replace this BJT amplifier with H parameter model. Okay, then we need to calculate all. Take it. Then I will replace, or let me replace now only, then let's see. Therefore, if I replace, right, we know that. What is that? This is nothing but HI. This is HI, and this is nothing but HR into V2, and this is what is our current gain, HF into I1, right? This is 1 by HO, right? Therefore, this is what is the BJT. Now, therefore, this is what is the black box, right? This is what is the black box. Now, you can make it ground, anything is fine. Now, let us apply your voltage source, the practical voltage source. This is your Vs, this is Rs, and the actual input to your amplifier. Even though this is Vs, this is real input, but the actual input to your amplifier is nothing but V1. Okay, and then the current which is entering into your amplifier is I1. I am speaking with respect to amplifier parameter, input voltage to amplifier, input current to amplifier. But the real source where you want to amplify the signal is nothing but Vs, if it is voltage source. If that is current source, Is, and then in parallel to Rs. That internal resistance of current source is replaced with in parallel to it. That you know, right? Practical current source. That is fine. Now the load is connected here. The load is connected. Remember, we are not exciting any voltage here. Okay? It is always like feed forward. Means when you apply the voltage, that Vs, then we are getting V1, then we are getting I1, we are getting V2. That is what we are applying to load. Okay? Where we are not applying any voltage. right? Then we are getting something. No, we don't want that. We want always something like this. Okay, fine. And this is what your RL, and this is the current which is entering into your amplifier. Therefore, according to two-port network, this is nothing but your V2. Okay. Now, let me speak with respect to amplifier. Already V1, I1, V2, I2, that is with respect to two-port network. But with respect to amplifier, this is nothing but input voltage to amplifier. Yes, satisfied with respect to input voltage from two-port network. The current which is entering into your amplifier is nothing but I1. Yes, satisfying with respect to the direction of two-port network current. Now, and this is what is the output voltage which you are getting from your amplifier, and that is what you are giving to load. Yes, satisfied with respect to two-port network voltage definition. But the current which is what is entering into the load is the one people say as load current. The current which is what is entering into the load, the current which is what is entering into the load is defined as the load current, right? But according to two-port network, the current which is what is entering into your amplifier is defined as I2. Therefore, if I speak with respect to source and load, right, because how much is the current the amplifier is pumping into the load, that is what is your IL. That IL is equal to what? With respect to two-port network model, that is opposite. Remember, anything is fine. If you take this is what your interested current, if real current is flowing like that, it will be positive. If real current is flowing entering into amplifier, that will be negative, right? Because the direction will be taken care by the magnitude, therefore that will be done with respect to minus or plus. Now, this is what is our BJT amplifier, excited with practical voltage source and connected load at the output. Now we need to calculate, for this configuration, we need to calculate all AC parameters: voltage gain, current gain, input impedance and output impedance. Okay, right? Then if you understand the definition of those four parameters, right, then derivation is straightforward and very easy if you know the H parameter model equations, right? What are those? Now you can write it. Therefore, already we know what is that. V1 is equal to HI into I1 plus HR into V2. Similarly, what is I2? I2 is equal to HF into I1. This is H parameter model equations only. And V2, HO into V2. Okay. This is what you can say equation star. Those things we use to calculate our AC parameters mathematically. Remember, we are doing mathematical analysis using two-port network model. Two-port network H parameter model. Okay. But your BJT will be supported by H parameters data sheet. The data sheet of BJT will have the H parameter values. Then those things can be taken, then we can use and we can calculate the AC parameters using the formula what we get now. I'm going to derive the formula. Okay. From analog circuits, we'll be having around 25 to 30 formulae, and if you know the derivation and if you remember those formulae and if you know how to use those formulae to solve the problems, I can say this is done. Okay, let's see. Okay, now let me define and then let's see how to solve one by one. Okay, I will not rub this part, maybe I'll use the remaining portion of the board to calculate, but that portion is also not enough. Maybe I'll derive after completion of that, I'll rub it and then do it. Okay, now let's see. Now the first one, current gain. Can anyone tell the definition of current gain? Current gain is defined as current gain of what? Current gain of your amplifier. Okay, that is what we are trying to define with respect to load and then source. Okay, now when I define your BJT amplifier current gain, okay, that is nothing but the amplifier what it is giving current to the load, that is nothing but your IL. Therefore, with respect to that, this is nothing but your IL. IL is equal to minus I2. What it may be? The current which is what is entering into your load, right? Because this is what your loudspeaker, let us say how much current your BJT amplifier is giving to your loudspeaker. That is what your output current, and how much current your BJT amplifier is taking from your source. Therefore, I am trying to calculate the BJT amplifier, the core current gain, okay, by your BJT amplifier. Therefore, the amount of current which is what is pumping into the load, which is load current, the amount of current which is what is taking from the source, which is nothing but your current entering into your amplifier. Therefore, if you understand the definition, what is the definition? Current entering into load divided by current taken from the source, which is nothing but I1. Current which is what is taken from the source. Therefore, this is what is current gain of your BJT amplifier, core gain. Okay. Now, what is IL? Once you understand the definition, now simply analysis, mathematical analysis, you will see. Therefore, what is IL? You can follow me. What is IL? IL is nothing but minus I2 divided by I1. Right? Now, we know already I2 from star. Replace, therefore substitute. If you substitute, what you get? Then minus I2 is nothing but HF into I1, HF into I1 plus HO into V2 divided by I1. Right? Then I1 will be cancelled. This is simply minus into HF plus HO into what is V2? Your V2 is nothing but IL into RL. Can I say that? Therefore, what is V2? V2 is nothing but IL into RL. Then what is IL? IL is nothing but minus I2. Therefore, minus I2 into RL. Therefore, what is V2? Can I replace V2 with I2? Yes, using KVL or Ohm's law. Therefore, V2 is nothing but minus I2 divided by I1 into RL. I am just separating it out because that is your current gain. What is minus I2 by I1? That is nothing but your current gain. Therefore, this is nothing but your AI and internally it is having AI. Therefore, AI is equal to minus HF plus HO into AI into RL. Then take this term to left hand side and then common AI, then you will get it AI. Simple, right? Then when you take AI common, 1, the minus will become plus, which is nothing but HO into RL is equal to minus HF. Then what is your AI? Current gain AI is equal to minus HF divided by 1 plus HO into RL. This is what is the first formula out of 25 or 30 formulae. Therefore, this is what is first. The first one which we need to remember, and we know the derivation also. If you derive, automatically you will remember. Okay. Therefore, what is current gain formula? But remember in the formula. Okay. But definition is very important. What is the definition? The current which is what is entering into the load from your amplifier, and the current which is what is taken by your amplifier from your source. Therefore, IL by I1. Then mathematical analysis, we got AI. I think you are following me, right? I didn't ask you to stop. Therefore, this is over. Then I can go to next one, the definition. Therefore, what is the definition? Second one, you may say voltage gain, right? But I am going with RI, input impedance. You will understand. See, because it is AC parameter kind of gain, I am taking capital letter. Even though this is AC, AC analysis, but the gains and all we represent with capital letters. That is the notation we follow. Okay, that's why you see here. These are all AC parameters. AC current and then AC output current, AC input current. But still, the ratio we are taking like gain, that is capital letter. Okay, that's fine. Therefore, similarly, what is input impedance? Definition: the impedance seen from input port of your amplifier. Therefore, what is your amplifier? This is your amplifier. Therefore, what is the impedance seen from input port? That is what is the impedance seen by your source. Your source will see that much impedance. Therefore, your voltages will be transferred, or currents will be generated, and the current will be entering into your amplifier. That's why RI is important. Okay, whatever may be, we will see the significance of RI as we go on or when we solve the problems. Okay, tell me what is the definition of RI? Definition of RI is nothing but the impedance seen into input port. How will you calculate? That is black box for us or something. Then how will you calculate mathematically? When you apply the voltage or when you have the voltage V1, then when you have the current which is entering into your amplifier, V1 by I1, that's it. Therefore, apply the voltage, get the current V1 by I1. That is what is your, but remember the I1 whatever you have, the current which is what is entering into your amplifier is due to the voltage what you are applying here, right? The current which is entering into your amplifier is only due to the voltage what you are applying. That is what is very important. Therefore, the definition Ri is nothing but V1 divided by I1. Ri is nothing but V1 divided by I1. Then, you know V1? Yes, from star. Substitute. Once the definition is over, simple, then just substitution. Then substitute. Tell me, this is nothing but Hi into I1 plus HR into V2 divided by I1. Okay, then I1 will be cancelled, then it is simply what? This is nothing but Hi plus HR into, what is V2? Which we already wrote before, which is minus I2 divided by I1 into what? RL. And what is minus I2 by I1? That is nothing but current gain. Don't substitute, we know already current gain in terms of H parameters, but don't substitute, keep it AI. Then if you want to solve Ri, first solve AI and then substitute AI. That is easy, otherwise it is bigger, okay? That's why it is having dependency. If you want to calculate Ri, first we need to calculate AI. That's why the flow is important. Therefore, Hi plus HR into AI into RL. This is second formula. Majority of the formula you get from BJT amplifiers and FET amplifiers. Okay. Therefore, two formulae are here only. Ri is equal to Hi plus HR into AI into RL. Okay. If you know H parameters and if you know load value and if you know source value, then can't you calculate the AC parameters? Yes. But for them we should know H parameters. Remember, no need to remember H parameters. Those H parameters will be given in the examination. Okay. Two parameters are over. Now the third one, voltage gain. We need to calculate only four parameters, four AC parameters, right? Now, what is voltage gain? Definition. Simply definition. Your output voltage, output AC voltage divided by input AC voltage. No need to say AC voltage specifically because this itself, small letter indicates AC voltage only. Change in output voltage, change in input voltage. All the definitions are like that. When I say output current, IL, change in output current, and I1, change in input current. All small letters are indicating change, which I already explained in the previous class. Okay. Now, therefore, what is AB? Output voltage from your amplifier, which you are applying to your load, right? Then input voltage, which is what is taking from your source. Therefore, output voltage, which is giving to load, input voltage, which is taking from the source. Therefore, this is nothing but your core voltage gain or your amplifier voltage gain. Okay. What is that? Therefore, that is nothing but output voltage which you are giving it to load, that is V2, and input voltage which it is taking from the source, that is V1. But remember, V1 is not Vs. Your V1 is not Vs. Okay. But real voltage gain with respect to source, if you speak, that is nothing but the voltage what you are applying to the load from your amplifier divided by the source voltage Vs, which is what is applied to your amplifier. That is what is with respect to source and load. But I am calculating only AC parameters of your amplifier, means the voltage what you are getting from your amplifier and then giving it to your load, and the voltage what you are applied or what the amplifier is seeing from your source. Therefore, we are calculating AC voltage gain. Later on I will calculate. It's not that we will not calculate, because the real voltage gain is nothing but V2 divided by Vs. That part we will see later. First of all, let me calculate only amplifier related parameters. Voltage gain, current gain, input impedance and output impedance. Okay, that is fine. That's why I'm saying, if you understand or if you are clear with the definition, right, then we can go ahead the derivation part. I think, what is V2? We already know V2 is nothing but minus I2 into RL. Then what is V1? V1 is nothing but what we have in the star, right? If you substitute, okay, again it will give you some complex equation, but if you solve, ultimately you will get it. But instead of that, that is redundant because we already have some relation where we can use it. Tell me, what is the definition of Ri? The definition of Ri is nothing but V1 divided by I1. What does it mean? We know what is effective input impedance. If you know what is effective input impedance, then what is V1? I1 into effective input impedance. That we can use it, right? Yes. Therefore, what is V1? I1 into Ri, and we know what is Ri. Therefore, let me write it as I1 into Ri. Therefore, what is minus I2 by I1? That is current gain into the load value RL and the input impedance Ri. This is what is our voltage gain. Straightforward, only one step to get it. But remember, to calculate voltage gain, we need current gain, we need input impedance. Then if load value is given in the problem statement, you can substitute, therefore we will get voltage gain. Therefore, we need to calculate first current gain, then input impedance, then substitute, you will get voltage gain. Okay? Therefore, your voltage gain is depending on current gain and input impedance. AV is equal to AI into RL divided by RI. Now take this, now only the last one related to your amplifier, AC parameters, right, which is nothing but output impedance. Okay. Take this, but anyway, if I start the fourth one, it is not straightforward. It needs some explanation to derive what is Y naught, what is R naught. Then let me stop now. Then we will continue in the next session to calculate the output impedance. Once the output impedance is calculated, I can say the 4 AC parameters related to your amplifier are done. Then later on, we will see the voltage gain with respect to the source, like V2 divided by Vs. Similarly, current gain with the practical voltage source. That time we need to exert with practical current source. Then output current divided by actual source IS. Let's calculate those two, voltage gain and current gain, including source resistance. Then with that I can say the BJT AC parameters derivation part is over. Then we can directly start solving the problems from the workbook. Okay. Therefore, whatever you are understanding now, theoretically we should apply to solve the problems. Not always theory we need to study, right? Once you understand the theory, whether we understood or not, that is what we need to solve by using the problems. Okay. Thank you. We will meet in the next session.